This lecture is a part of the interview process for professorship in School of Earth Sciences, Srtmu University, and I am delivering the talk in the presence of Professor Gary Ernst at Stanford University. And in the talk I am going to discuss and describe about the growth of the continent in the southeastern margin of India. The continental crust is the basis for the origin and sustainability of human life. Is basically originated by two processes. One, the horizontal subduction, where the subducting lithosphere gets recycled and the continental crust is generated. And second, by the vertical tectonics, where the hot jet of plume, the mafic magmas derived from the plume, are poured onto the surface of the earth and construct the mafic crust on the surface. So these two are the important processes for the generation of the continental crust. And when you look into the Indian geology, we have the continental crust grown from different times. We have the cratons grown at a period of 3.4 to 2.6 billion years back, and we have the Himalayas and the Andaman Nicobar Islands, which are still growing at present. And my work at Stanford University is to understand the tectonothermal evolution of the Eastern Ghats Belt, which has a long history of 1500 million years, from at least 2 billion years to 0.6 billion years. And to understand this Eastern Ghats Belt, the present understanding is, we know that from west to east there is a decrease in the ages of the magmatism and as well as the sedimentation. But the timing and the processes of how this phenomena has taken place, we haven't understood better. And to understand this entire evolutionary history of the Eastern Ghats Belt, we have taken up the work on the zircons by using the sensitive high-resolution ion microprobe. The purpose of the choice of the zircons is because they are robust geochronometers, because once they are crystallized in the magma, they are not going to be disturbed by the later deformational and metamorphic events. So as we can see, we have a complete history from more than around 3,000 million years to around 540 million years embedded in the zircons of the Eastern Ghats Belt. So for the first time, based on our work in the Stanford University, for the first time we have identified two Wilson cycles. The first Wilson cycle is the Paleoproterozoic crustal growth, which is between 1.9 and 1.6 billion years, which is a Pacific type. We have the rifting taking place at 1.9, the continental arc formation at 1750, and finally the suturing, the continent collision at 1.6 billion years. The opening of the ocean and its closure is what we call as the Wilson cycle. So this is the first record of Wilson cycle in the Eastern Ghats Belt. And we have a second Wilson cycle, which has a history from 1350 to 1000 million years. Again, there is a growth of continental crust. In the first cycle, we have a continental crust grown for around 200 kilometers, and in the second event, we have a crust which has grown around even 400 kilometers. And this is a Himalayan type of Wilson cycle, where we have a very little arc formation and more of a continental recycling. And we have a third intracrustal orogeny in the Pan-African times. This is more an intracrustal orogeny in response to the far-field stresses. So these three cycles of evolution of crust in the southeastern margin of India has global implications, because the first Paleoproterozoic growth of Eastern Ghats Belt is related to the formation of the supercontinent Columbia around 1.6 billion years back. And the second cycle of the crustal growth is related to the formation of Rodinia during the Greenvillian times. And the third cycle of crustal orogeny tectonics, which the Eastern Ghats has witnessed, is in tune with the formation of the supercontinent Gondwana. But the Srtmu University, Nanded, which is located not on the crust formed by these subduction-related environments, but on the crust which is generated in a plume-related environment. Flooding of lavas from a plume around 65 million years ago is the crust on which the Srtmu University is presently located. So we have my parent institute, Swami Ramanand Tirth Marathwada University, which was established in 1995, is situated on a plume-derived crust which was formed 65 million years back. And my host institute is Stanford University, which was established in 1891, and it is situated on a subduction-derived crust which was as old as 175 million years. So this fact reinforces the observation reinforces the fact that the geological and human relationship do not have any geographical boundaries. Thank you very much.